All right, so since solving trig equations is something that typically is quite difficult for students, here's a video on, that works out the exercise that you were intended to try in the solving trig equations video. Okay, so 2 sine squared of 2 times quantity sine squared of x plus 2 equals 3 quantity 1 minus 1 over cosecant of x. I think where I'd start here is we see a reciprocal here. And not only that, but it's a reciprocal of one of our lesser favorite trig functions, cosecant. So it should put a smile on our face to use our reciprocal identity and turn that into just a more familiar and more comfortable sine of x. 1 over cosecant is equal to just plain old sine of x. So 1 minus, and then I'll put the 3 here. I think I'll just leave this side alone for this step. And then on the next step, I'll just distribute. So no trig identity, just distributing. 2 times both of the terms inside those parentheses would give me 2 sine squared of x plus 4 equals, and on the right side, 3. Again, make sure you distribute. As I mentioned before, students seem to just forget all their algebra when you start throwing trig in the mix, so make sure you distribute. And remember in the example, I hope nobody got misled by this, but remember in the example we ended up using a trig identity and we replaced, I think it was a cosine squared with a 1 minus sine squared. I hope you caught the reasoning on that. The reason that was beneficial last time is because at that time we didn't have all the same trig function in the equation. I think we had like a sine of x, but then this was a cosine squared of x in the example. So using the Pythagorean identity got us all sines of x's. Well, take a look at this. We're already in terms of all sine of x. There are no cosines or any other trig function, so don't use the Pythagorean identity here. Let's keep it all in terms of sine. And let's just do a little rearranging, and let's put it in that quadratic form, that standard quadratic order of quadratic term first, 2 sine squared of x. We'll take the linear term, the 3 sine of x to the 1 power from the right side and move it over to the left. And remember, you're really adding it over to the left. And we'll take the plus 4 on the left and subtract the 3 on the right, and that'll give us a plus 1 here. And once again, just like the example, let's look at that quadratic and cross our fingers and see if factoring does the trick. And as I indicated in the main video, factoring 90-something% of the time will work. And if it didn't work, you would use quadratic formula or completing the square. So like last time, we're kind of lucky here that this coefficient is just a 2. There's not really too many ways that can split up. So 2 sine x times sine of x would give me my 2 sine squared. Again, we're lucky a little bit here too, that with the constant term of 1, there's not really too many ways that can split up. And in this case, a plus and a plus will do the trick. Again, pause, let's just do a quick mental check. 2 sine x times sine x gives me the 2 sine squared of x. Outer term, 2 sine x plus 1 would give me plus 2 sine x plus another sine x. That does give me my 3 sine x. The last term in the FOIL does give me the plus 1. So yes, it all checks out. Okay, so this is the point where we set each of these factors. And remember, one thing that I find students doing is that quite often they'll have something that's not 0 on the right, and then they try to set these factors over here on the left equal to 0. You can't do that. You can only set the factors on the left equal to 0 if the right equals 0, and it does in this case, so I am doing it correctly. But again, if this were not a 0, you would not set the factors to 0. So like in the example, I'm going to do this a little bit quickly. We should feel a little bit more comfortable with where we're at right here. And I'll expect that you come see me if this is not making sense. So 2 sine of x equals negative 1. That means sine of x equals negative 1/2. And I'm going to go ahead and just do this one on the right too. That would say that sine of x equals negative 1. Let me do it a little differently than I did in the main example. I'm just going to draw a 1-unit circle and try to get all these solutions. So sine of x equals -1/2. That would be down in the 3rd quadrant, shallow, and the 4th quadrant, shallow. And that would give us 7 pi over 6 or 11 pi over 6. Unit circle skills to the rescue. Where does sine of x equal -1? I think that was one of the solutions we had in the last one. It was that quadrantal angle, right? 3 pi over 2. So those are our 3 solutions. 7 pi over 6 plus 2 pi n. I'm not color coding this real well, but 3 pi over 2 plus 2 pi n. 11 pi over 6 plus 2 pi n. X equals all of those. I'm sure some other math teachers would probably criticize that I'm not being a little bit neater, but I feel like it's legible. I went down the page. It's all in a box. That's good enough for me. All right, let's take a look at how this would check out graphically. If I planned ahead a little better, I would have, again, gotten the color coding a little better than this. So graphically, this is one that's a little bit hard to check, I will admit, because notice how in this part of the graph, all those intersections are all bunched up, and it's really hard to see exactly where the intersections occur on the calculator. So again, I acknowledge that sometimes it's more difficult than others to check graphically, but that doesn't mean we should just give up on it. So try it out, try the checking graphically, verify for yourself that your graphical solutions do match the algebraic solutions, and we'll keep working on that in class and in office hours.